My name is Patrick Gaydecki and I'm Professor of Digital Signal Processing in the School of Electrical and Electronic Engineering. I'm associated with the e-Agri project with regards to research, a feasibility study project, which is in collaboration with the University of Lancaster. And the subject of research is insect tracking during the daytime, in particular the monitoring of bee movement above the crop canopy. This is a particularly difficult task to accomplish during the day because at distance it's very difficult to see small insects against a bright blue summer sky. The methodology that we have adopted is one of infrared illumination at 780 nanometers. And the reason that we have selected that frequency is because although in space the sun acts as a black body radiator, sunlight reaching the ground is weak in the wavelength at 780 nanometers because of atmospheric absorption through oxygen. So the principle of operation of detecting flying bees is illumination of a volume above the crop canopy with a laser operating at 780 nanometers, and downwind or downfield from that, operating in the forward scattering regime, we have a camera which is fitted with a 780 nanometer filter. So the only thing that the camera will see, and the camera is also sensitive to the infrared, is anything that is forward scattered, in particular from the bee wings. The reason that this is a useful thing to do is because almost all crops are pollinated by wild insects, and most of those are bees. But very little is known about bee pollination behaviour, in particular flight behaviour. So this project is an opportunity to quantify bee movement and establish the relationship between bee activity in the crop margins, where often plants are sown to allow bees to, so as an area for bees to live, and then they fly across the crop for pollination purposes. So it's that relationship between the crop margins and the crop itself which is of importance and significance when we consider insect movement above it. We have a lot of DSP research which is commercialized, but this is an early attempt to recreate, in fact, some of the work that I undertook for my PhD, which again was in insect movement monitoring. Most of my research at the moment is in digital signal processing, digital image engineering, digital image processing, and that is in relation to audio, biomedical and non-destructive testing. This is in effect as a rebirth of some of the ecological physics work that I used to do. Depending on the successful outcome of the project, we certainly anticipate that there will be opportunities for MSc and PhD project students. If the pilot project is successful, we plan to extend it with a much larger project involving correlation with meteorological variables. And the whole point about this exercise is it can be extended not just to conventional crops, but also to orchard situations. And ultimately, the objective is to improve yield. So for the farming community, this is all about efficiency of yield. It can also be extended, instead of looking at pollinating species, to look at pestiferous species. So imaging of midges, which are disease vectors, in particular the blue tongue virus. So it has important economic consequences for the farming community.